Welcome to the video lecture series of data structure. Today we are going to learn about that how can we perform the insertion operation at the end of the linked list in Singly Linklist. Hi, this is your instructor Janice Shah. So let's begin to understand that how can we go to insert a data element, or we can say node, at the end of the linked list. So algorithm for the insertion at the end of the linked list. Students, let me remind you some basic point of the introductions of the linked list. See, while you are inserting anything in a singly linked list, do not forget that after performing the insertion operation, you need to return the address of the first node of the linked list. That's why in our algorithm, we are going to take it as function, not the procedure. Second thing, in linked list insertion, obviously we have the parameters which shows the linked list. How you can identify that this is the starting point of the linked list or this is the starting point of the linked list? To identify this, we have the value of the first pointer. Students, the first is a pointer which is pointing to the first node of the list. So that's why in my parameter value, I am taking first comma x over there. You can see the first is representing the first pointer which is pointing to the first node of the list, and x is a data element which we are going to insert over there. Now, another thing I want to remind you that in our this algorithms, we are going to take the data as info and pointer as a link, as our whole node contains two things. One is data, one is pointer, and we consider them as info and link respectively. Fine. So let's begin with the very first step of the linked list. Students, I already told you in my previous sessions that while you are inserting anything in the linked list, when you try to insert something in the linked list, you want a node that is going to be inserted in the linked list. How to get this node? You can get this node from the availability stack. So students, here whenever we want to insert any node in the linked list, we should go for the availability stack, ask him to give us the node, and then we take the node from it, then place at the respective position on which we want to insert. Fine. So again, see, the linked list is an insertion algorithm, but here we are not going to do any overflow condition checking. Why? Because linked list is whenever we want to insert anything in the linked list, it is come from the dynamic memory allocation. So when we talk about the dynamic memory allocation, there is nothing like a fixed size data structure, because array is a fixed size data structure. Linked list is not a fixed size data structure. Fine. So here you can add as many as nodes you want to insert. Fine. But the condition is only that your memory must have the enough spaces to give you enough free spaces to give you the node. How to get it? We are going to take it from the availability stack, and for that we must need to check the underflow condition for the availability stack. That's why the very first step is very much common in the insertion algorithms of the linked list. That is, first step is to check whether my linked list is underflow or not. So here it is. See, this is my availability stack, and I'm going to check the underflow condition over there. If my avail pointer is pointing to null, see, when my availability stack is empty, when my availability stack is empty, my avail pointer is pointing to null. Fine. So that's why very first step is to check whether my avail pointer is null or not. If is that so, then it means that availability stack is empty. Okay, and return first. Again, from this first step, if your availability stack is empty, your algorithm is completed. You have to return the value of the first pointer to the end user. Fine. Now the next step number 2. If is that not so, availability stack has some spaces to give you the node, then you first need to assign a new pointer value to availability stack. Now again, remember that who points to who? Who points to whom? Here I am going to point new pointer to avail it with avail space. Fine. So new to avail. So the statement is new arrow avail. So see, second number step is obtain the address of the next free node. How can you get the address of the next free node? Okay, so you just need to point out new to avail because avail is the next free node. And new is a new pointer which is pointing to the always a new node. Now we have assigned a new pointer to the avail pointer. Fine, we have already assigned it. So now we can easily move the avail from the avail to link of avail. Because if this is avail, then the second node, the below node of the avail is known as the link of avail. Fine. That's why we need to move our pointer avail from avail to link of avail. So just like this, your second number step is known as removal of the new node from the availability stack. Why it is known as removal? Because when you go down from avail to link of avail, when you go down from avail to link of avail student, your stack becomes like null to avail only. So the above node from the avail, above node of the avail is already out from the stack. So we can easily say that we have removed it. We have removed it, the new node from the stack. Fine. That's why the step number 3 is avail to link of avail. That's why we have to write a perfect statement in step number 3 that remove free node from the availability stack. So students, right now you have your new node. The node which contains data and pointers. So let me show you how your new node looks like. So here it is. Students, your new node is there. And now you have to initialize the fields of the new node. Students, every node contains two different things. One is data, one is pointer. One is data, one is pointer. In our algorithm, we consider data as info and pointer as link. We know data as info and pointer as link. Now, let me know when we talk about the info of the new element. Sorry, info of the new pointer. Okay, then what is the how can you write that? You need to write like info of new is equal to x because we have to put the x over there. That's why the very first step of initialization of the new node, that is just write down info of new arrow x. Now, second thing, what will be the link of a new node? What will be the link of a new node? Okay, now let me know in this algorithm what we want to do exactly. Students, we want to insert a new node at the end of the linked list. Fine. Now, let me know if my linked list, if I want to insert a a node at the end of the linked list, then what is the value of the link? That means the data, the pointer of that last node that is pointing to null. Because as I want to insert it as last node, that means it will become our last node. So we can easily say that the pointer of that last node must point into the null just because this is a single linked list, not a circular or double linked list. Fine. So what we need to do is we can directly assign the link of this node in this particular step. So I can write over there that the link of new is also a null. See, in many times students in algorithms, you are not able to decide that, sir, I can easily decide that I just want to insert x over there. So I can write like info of new is equal to x. But it is not good for me to decide how what is the link of the new. Okay, so always remember you have to draw a figure in your paper during the exams and try to decide to understand this algorithm and try to decide okay where I want to insert the particular node. I want to insert it at last. Okay, so after that is there any node? No, because this is the last node. So its link must be pointed to null. Fine. Okay. So what the next? Let me show. This algorithm has very much conditions. like we can insert, you can insert directly this node, but it might be possible that your linked list does not exist. Then what? It might be possible that your linked list must have only one value. Then what? Okay, so such type of various things you need to take out, look out in this algorithm. Okay, so next step number 5. See, you have just created a node with a value x only. Okay, so I am just repeating that statement number 4 over there. So you have just created a new node only, students. You do not have anything. Okay, now the next step number 5 is the condition. The first condition you need to think about a situation where your linked list does not exist. Okay, students, tell me when your linked list does not exist. Fine. At that time, what happens? Okay, let me remind you one thing. If my stack does not exist, then top pointer must be at 0. If my queue does not exist, then the front and rear must be at 0. If my linked list does not exist, then my first pointer must be at 0 or null. That you need to think of. Students, again I'm repeating this. If my linked list does not exist, that means my first pointer is pointing at no one. That means 0? No, wait. This is a pointer. It cannot be 0. It must be null. That means when your linked list does not exist anyway, then your first pointer is pointing to null. Remember the statement. Again, just write down in your notebook that when the linked list does not exist, your first pointer. Repeat. When your linked list does not exist, your first pointer must be null. So how can you check the condition whether your linked list will exist or not? So if your first is equal to null, that means your linked list does not exist. Right or wrong? Right? That means this whatever the node you get from the availability stack, that will become your first node. That will become your first node. And it also your last node. Because only one node is there. Right or wrong? Okay, because linked list does not exist. That means there is no nodes. Now, whatever you are inserting, that will become your first, that will become your last. If it is the first, that means the first pointer must be pointing toward that only. And if it is the last, that means the pointer, the link of the new node must be at null. And we already did it. So what is left over here? We just need to write return new. Sir, wait a minute. In underflow condition, you have return first, right? But in this condition, you write return new. Why? Students, obviously, in underflow condition, if the linked list is there, then I have to return the value of the first node, correct or not? Yes? Okay. Now, here in this situation, my linked list does not exist. At that time, the new node becomes my first, the new node becomes my last. That means what I need to return is, I need to return new because it is my first only. Fine. So now let's move towards the next condition. Now the next condition is that if my linked list exists, students, make sure you have to see this animation over here in PPT with a good observation skill. That see, my next condition is if my linked list exists, then what? Okay. So I have one linked list over there with the values like 10, 40 and 50. 10, 40 and 50. Then 50 is the last node, that's why it's pointed to the null. And then 10 is my first node, that's why the first pointer is pointing to at 10. Fine. Okay. So what to do, students? What to do? I want to insert my new node. Remember, I want to insert my new node. At which position? At the last of the linked list. Correct or not? Yes? Now see, it's 10, 40, 50 and then after it, after 50, my new node must be situated, must be inserted. Fine. So for that I have already prepared. I have drawn this figure. I have the 10, 40 and 50 and I already put my new node over there. See, I already put my new node after 50. So what I need to think is anyhow I need to connect the link of the 50. I need to connect the link of the 50 to the new node. Fine. This is what I need to think about today. Okay. So to connect the link of 50, what I need? I need the name of the 50. Students, is there any pointer is pointing to 50? Yes or no? Is there any pointer is pointing to 50? No. Okay. So what to do? We need to assign a name. That means we need to assign a pointer to 50. So how to do this? You need to go from the first node of the linked list to the last node of the linked list, and then the link of the last node will connect to the new node. If this is my last node, if this is my last node, then the link of the last node will connect to the new node. This is what you need to perform. But for this, we need to assign a pointer to last node. That means we need to go from the first node to the last node. Now, if you remember my very first lecture on the data structure, I told you about the various operations. I told you about the various operations of data structure, like searching, sorting, merging, traversing, insertion, deletion. Fine. So the operation in which you are accessing each and every element of the data structure at least once, that operation is known as traversing. So here, what we need to do? We just need to move from first node to last node. First node to last node. So how can we do this? Our journey from first node to second, second to third, third to fourth, fourth to fifth. How can we do this? How? Let me show you. Here it is, students. What I'm going to do is I'm going to initialize one pointer that is known as save pointer. You can also known as a temporary pointer. Okay. I need to initialize the save pointer to search the last node of the list. If I'm going to put it save pointer over there, okay. So what I have right now, I have only one pointer that is known as first. So I know the beginning of the linked list. I know the beginning, the first position of the node, first position or the first position of the first node of the linked list. So what I'm going to do is I'm going to assign save pointer to the first. I'm going to assign save pointer to the first. That's why this step is known as initialize search for the last node. And to that, we need to initialize a save pointer. We need to take a new save pointer and assign it to the first. So what happens right now? If this is my first node, students, if this is my first node, my first pointer is pointing over here and the save is pointing over here as shown in this figure. Fine. Now, let me know one thing. If this is the save, if this is save, okay, then what is the name of the next node? If the name of the 10 is save, it is name also is also first, because I already assigned the first and save both over there. Okay, then what is the name of 40? Students, name, that means if your pointer is pointing to the particular node, then what I say, its name. If the save pointer is right now pointing to the 10, that means the name of the 10 node is save. It is also first. But for who is pointing to the 40? Who is pointing to the 40? Okay, see, the link of 10 is pointing to the 40, yes or no? The link of 10 is pointing to the 40. Just understand this in a good way, okay? This will clear all concept about the traversing of the linked list. How can you search in the linked list? Each and everything. This is very important theory, okay? How can you go, how can you initialize a temporary pointer and initialize at the first position of the linked list and move towards the next. This is will happen. See, if I can say that at the 10 has the save, that means the save pointer is pointing at 10, that means the name of the first node is save. Now, the link of 10 is pointing to 40. That means a link of save is pointing to 40. Yes or no? The link of save is pointing to 40. That means if this is save, then the name of the next node is link of save. Correct? Now, this is what I want. This is what I want. See, I need to move the save from 10 to 40 to 50 to 60, whatever the last node it is. Now, tell me students, how can I identify that this node is my last node. How? This node is my last node. How can I say this? So this is your last node because this node must contain a null pointer value. That means its link must pointing to null. And then you can say that this node is your last node. Yes, you are correct, students. What I'm going to find out over here, I'm just going to find that which node's link is pointing to null. Okay, so if this is save, this becomes link of save. This is save, the next will become the link of save. I am moving the save. I am moving the save pointer from one to another, one to another, one to another, and when it reach to the last node, its link become null. Its link become null. That's why the next step is repeat the step like search end of the list. We need to search end node of the list. Okay, so we are going to do that. How? See, repeat while until and unless your link of save is not equal to null. So students, repeat while until and unless your link of save is not equal to null. Fine. So what I need to do is, I have already write the condition that repeat while link of save is not equal to null. And then what I need to do is, see, if this is 10 is save, then the next node, the link is known as link of save. Fine. So what I need to do is, I need to move save to link of save. Okay, until and unless your link of save becomes null, you just need to move save to link of save, save to link of save, save to link of save. Fine. So I'm going to do the same thing over here. Okay. So see students, the above figure, see the animations. Okay. Now, right now my save pointer is at 10. Now check the link. Is link of the save is null? Yes or no? No. Then it will move further. Now again the repeat the while step, the loop is going on. Step number 7. Again it will check whether the save is now at 40. Now check the link. Is that null? No. Then again save will point to link of save. Who points to whom? Save points to link of save. Who points to whom? Save points to link of save. So save will move to link of save. So here it is. The save will move towards the link of save. Now check the link again. Check the link again. What is the link of save? What is the link of save? When the save pointer is at 50, what is the link of save? It's a null. It's a null. At this time, the loop will stop its execution and move towards the step number 8. So students, you have already reached to your destination, that the name of the last node is save. Okay, you got it. You got your final node, or you can say last node. So what we have right now, we have the save pointer which is pointing to the last node of the list. So what do you see? This is save. This is the 50. This is my new node. I just need to connect the link of the 50 to new node. Link of the 50 to new node. If this is 50, I am going to connect the link of the 50 to new node. The name of the node 50 is save. Save. Then what I need to do is, I just need to write the link of save to new. Link of save to new. So that's a last step of this algorithm, that link of save is pointing to new. With this, see that this, your link of save is directly connected to new, and then your node is inserted at the last position. Now after inserting the node at the last, what is the address of your first node? That is first pointer. You just need to write return first. Fine. So this is how you can perform the traversing operation. This is how you can search the last node of the linked list. Fine. So that's it, all about the lecture, students. If you have any doubt, then please feel free to ask me. Thank you so much.